So before we proceed to lecture week number 3, I think we better finish first. This one coming from lecture last week. So we stop here. So I will try to finish up the remaining chapter of array and pointer, and then we proceed to lecture week number 3. Okay, so this one is a continuation from chapter 2. We covered that in programming. So the last one, the last part chapter, the array and pointer. So looking at this current slide, so array is similar to, as you can see from here, array is similar to variable, except that we use array to hold multiple value coming from same data type. So this one I will explain later on. So let's say we have a list of variable. We have many variables of the same type. So this multiple type of variable we can refer to same name. Okay? Same name of variable through array. And the multiple number of array of variable located in array, we call it array element. So if you looking bottom, the last one, declaration for one dimensional array. So normally we have many type of array. So this one we can have one dimensional. We can also have two dimensional. We can also have three dimensional. So if you are dealing with two dimensional, it is similar to table. Okay, so let's say square bracket 4 and then another one 5. So this means that it is two-dimensional array with 4 row and 5 column. Okay, so we refer back to the previous one. Okay, let's say we have one-dimensional array. One-dimensional array. This is how we type the array by following the syntax here. Type variable underscore name and then size. Okay, so type would be the data type of that array. It can be char, it can be long, it can be int, depending on the type of data that you want to use. And then we give specific name to the array. Okay, so better if the data is referring to temperature, we give some kind of name that could represent the temperature. Okay, would be easier, but however the name is, you can put any name you wish. And then the size, which is here, the number of array element. Okay, so you can specify how many array that you want to have. For example, integer height, the array name is height, the data type is integer, so the array element is 50. So this means that we can put 50 array into the 50 variable into this array called height. So the data could be the length, the height of certain student, the type of people. Okay, so that one we group into height. So you can see here the first element to be at index of 0. So basically the first element or the array element always start at 0. So if you have 50, so this means that the end, the final element would be at 49. Okay, so because it always start at 0, and then the last must be index size minus 1. So if we have 50, so it could be 49. And then how do we assign value for the array? For example, the first example, int height 3. So this means that the array element must have 3 variables, 23, 45, and 67. So by putting the size here, so we need to put 3 number, 3 variable. And then if we leave this one empty, okay, by putting only empty bracket, okay, so this means that the size is not fixed. Okay, we can put 3 size, we can put 4 and so on. And then if we are dealing with string or alphabet, we can always use this type of format. Okay, the bracket is still the same, but the inside between number and also alphabet. So you can see from here, Okay, let's say if you want to declare, assign the name here. Okay, so to array called name, so you need to know the number of string here of character. Okay, and then so you can see here 7 1 2 3 4 5 6. Okay, and then plus this one, okay, which is /0. So what you see here, /0 is a null terminator to indicate the name of string. So if the name stop at I, so you put here, okay, so that it will inform the microcontroller that there are no more string after the I, okay, to indicate the end of that string. And this is how we place the array, the variable inside the array, okay, by using the example height. So you can see here, let's say this is the first one, second, and then third. So actually this is the first, second, and third. But since the index number always start at 0, so at 0, 0 memory location, so the number would be 23. Okay, so the variable, the data, and also the location, the memory location is different. Okay. So we can try observe some of these example here. So if you look at example number 1, so this means that we have array C, name, the group name is C, and then the element is at 0. So this means that only one, okay, only one. So this means that we want the value inside array C at location 0, the data inside this array to be transferred to A. You copy and paste it into variable A. And then for C, with element 1, so this means that we need to put 1, 2, 3 here into the array index location at number 1. Okay, so this means that we need to put at second element. Let me. Okay, you can by referring to example number 2. Okay, so C0 and then C1. Okay, so you need to put to 1, 2, 3. Okay, so this one. So this one no need. So you just consider at array number 1, element number 1. And then for number 3, array I at element number 2. So do the same thing. Okay, so we put 1, 2, 3, 4, 5, the value of 1, 2, 3, 4, 5 here into the third element. Okay, and then the last one, we multiply. We multiply the value inside array I, element number 4, with 1, 2, 3. And then that particular value, we copy and then paste it into array K, element number 3, which is at index number 1. Okay, do you have any question? Okay, so no question, we proceed to another two pointer. So similar like variable, but the pointer, the behavior of pointer is slightly different because it is a memory location of a variable that only hold an address of another memory location. So when we refer pointer only deals with memory location, but variable it only deals with data type. And this is how we declare pointer. So type and then star and then var name. This one is the name of the pointer. Okay, you need to put a specific name for the pointer when you want to program something that involve pointer, and then the type must be int, integer, char, depending on the size on the data that you want to store. And then for pointer, it must have this character, which is star. So to indicate that this variable is actually a pointer variable. So this means that it will store the address, not the data value, but the address. So for example, okay, we declare pointer A as integer, and then we have array with size element 4, okay, for array element. So with the value, respective value 1, 2, 3, and 4. And then A equal to n height. So this is a character, we call it ampersand. So whenever we operate with pointer, we need to put this character, okay, the n character. So this means that we assign the first address of A, the first address of height 0 to A. Okay, so this means that height 0, how much is the value? We store at height 0, what is the address of height 0? Okay, and then you put it into A. And then you increment A, and then lastly you display the value of pointer A. Okay, so not the address of A, but the value of pointer A. So at height 0, the value is 1. So when you increment, okay, so the previous location is at 0, but the current location is 1. So you put 2, okay, because you increment by 1. Okay, if you keep this one, or you cancel out this one, so this means that we only display the value of height 0. But since we increment the address of A, so the value would be number 2. Okay, so this one, normally we can compare it, the array element as a lookup table. Okay, so it is similar to lookup table. So the table you see here is a summary, summary of comparison between array and pointer. Okay, so looking at this diagram, okay, so array, the size of array, the array element is up to 5. Okay, and then this is the location. Okay, starting with 0, 1, 2, 3, and then 4. Okay, so everything, the data will contain into this array, but the location, okay, is shown here. Okay, so declaration, so you can see here the difference. Okay, so the difference is that you can see is the star here. Okay, star here. So array, we can store variable, the value of variable data, but for pointer, we can only store address. Okay, and then the storage pointer designed to store address of variable, but for array, we use it to store value of variable. Okay, so the capacity, an array can store number of elements mentioned in the size of a variable. Okay, the size would be here. Okay, depending on the size. Okay, so if you declare the variable size is 4, so this means that it could store up to 4 data, okay, 4 array element. Okay, a pointer variable can store the address only one variable at a time, so cannot go more than one, cannot store more than one. Okay, so do you have any question before we proceed to the next one? Chapter number 3 or week number 3. Okay, so we continue. So for this week, we're going to look at lecture number 3 for week number 3, which is input and output interfacing. So basically, some of the learning outcome that you will study, that you learn this week, you will see the basic interfacing circuit that we need to assemble when connecting to a PIC. And then after that, we're going to look at typical input and output circuit that we can build, that we can design when connected to a PIC microcontroller. And then we're going to see how do we implement this in terms of hardware and also software. Okay, so we start by referring to this figure first. This is PIC 16F74/877A. So the code here stated that for these two codes, the setting here would be the same. So you can see here, this is for, okay, I will refer this as 877A since you are going to use this throughout this semester. So you can see here, this is the PIC microcontroller, 40 pin deep, okay, 40 pin, dual and package, and then you can see each pin has their own respective function. Okay, and then some pins, certain pin, they have more than one function. So right now, if you look at this table, right now we try to concentrate on this pin value first. Okay, so to start, there are 7 pins that we need to know in order to make the PIC function correctly. So we will start by looking at pin number 1. Okay, pin number 1, which is here. Okay, this one stands for MCLR. So you can see here we have upper line, and then upper line here you will see it later. So basically it is for miscellaneous reset. So this means that we need to reset. We would go to this button. If you want to reset the program, you need to go to this button. And then 11 and 32. 11 and 32, this one would be the positive supply. And then their respective ground at 12 and 31. So you can see here, 10 and 11, 32 and 31, their respective ground for the positive power supply. And then 13, 14, this is the pin that you connect, that you need to connect whenever you want to connect an external clock to the PIC. So for this pin, we need to connect it to an oscillator or crystal oscillator. So for these 2 pins, okay, so the first one, we will look at the assembly of supply circuit to the PIC. So if you want to connect the PIC microcontroller to an AC power source, okay, especially to the grid, so the system always start at 200, around 220 AC. This one is AC, and then from here we drop the value from 220 to around 6 to 12 volt. Still AC, still AC, and then the AC signal will be converted through this full bridge rectifier, and the value is still 6 to 12 volt, but it is right now a DC circuit, okay, a DC source, okay, a DC voltage. And then we go to this capacitor. So this one to smooth out output from the full bridge rectifier, and then the value is still around 16 to 12 volt. Okay, 12 volt DC. Okay, and then this one LM7805. This is a specific regulator. So this means that any value higher than 5 volt will be cut to 5 volt. Okay, so this is what we are using when we want to connect to PIC microcontroller, because PIC input voltage can only receive around 5 volt. It's not more than that. Okay, so we need to use this one to regulate, but make sure that the input must be the DC source. Okay, DC source. And then we have 2 capacitor is in parallel to filter out, to smooth out output from this voltage regulator. So after this signal for 5 volt, we will represent it as VCC. So you can see here, this is how you connect. For VDD, I think 32 and 33, 10 and 11. Okay, 10, 11. So this one also need to be 5 volt. Okay, 5 volt and then ground. Okay, so we look at another one. This is the circuit, okay, interfacing circuit that you need to build, that you need to assemble when you want to connect to MCLR, okay, to the reset. Okay, since if you refer to this diagram, so upper line, so this means that the pin here will only receive 0 okay, when the program, the microcontroller, receives 0 from this pin, it will reset the whole system. Okay, so you need to put 0. Okay, if you want to enable the reset. Okay? So, but what if you want to use the program, you want to use the microcontroller, so you need to put high here in order to disable the reset. Okay? So you need to put continuous, continuous high or 5 volt. If you want to reset only, so you need to give 0 or low, or 0 volt. So the circuit shown here is a basic switch circuit. Okay, so we have here is a limiting current resistor, and then right now you can see before the switch, this is a press button switch. Before the switch being pressed, 5 volt will enter into MCLR. So this means that the reset will be disabled. And then if the user wish to reset the whole system, just press this one, and then the current will flow through here. So potential, the logic value here will be 0. So when MCLR receives 0, it will reset the whole system until the next condition become high, until the operator, the programmer, the user release this button, then the value here go back to 5 volt. And then how do we connect to an external oscillator? So by referring this one to OSC1 and OSC2 located at pin 13 and 14. So this is the pin that you need to connect to an external oscillator. So you can see here the arrangement. Okay, what we have here is a symbol for oscillator, and then every oscillator before going to ground, they must be connected to a pair of capacitor, in parallel, parallel before going to the ground. Okay, so and then if you refer to this table here, we have 3 type of crystal oscillator that the microcontroller can be connected. Okay, that the microcontroller can recognize. So we have LP, XT, and then HS. So for LP, the frequency range is starting from 32 up to 200 kilohertz. So if you're using oscillator type LP, and then the frequency between somewhere around this range, so this is the value that you need to use before you can connect here. Okay. So if the oscillator type is LP and the frequency range is up to 32 kilohertz, so you need to put 32 picofarad. So this means that here should be 32 and 33, and then this one also 33 picofarad. Okay, the value must be same. Okay, and then the value will change according to the type and then crystal frequency. So you can view from this table. And then after that, the previous one is the basic that you need to know, starting with power supply and then reset and then the oscillator. So right now we're going to look at input and output interfacing. Okay, so how do we connect, how do we build our circuit if you want to connect to the microcontroller. And then after that, we're going to look at how do we program. Okay, so right now, we know that for PIC 16F8778, it contains up to 5. Okay, 5 ports starting from port A, B, C, D, and E. So each respective port has their own bit size. Okay, so the number is for port A up to 6 bit, okay, or 6 pin. Okay, but for port B, port C, and then port D, they have each respective port here contain up to 8 pin or 8 bit or 1 byte. Okay, and then for the last one, port E, the smallest pin, the lowest pin up to 3 pin.
Sir, tak ada suara.
Sir, tak ada suara sir, tak bunyi.
Sir, sir, tak ada suara. Sir, tak dengar suara.
Okay, boleh dengar?
Boleh, boleh.
Boleh.
So we proceed. We proceed to the presentation. Okay, still can hear. Okay, so we go back to this table. Okay, so this is the register that you have learned contained into this special function register, and you can view all the type of SFR, special function register, through the datasheet. Okay. If you refer to table 2.1, so you can see okay, there are more than so there are more than port A, port B, port C, port E, and also tricks A. So right now we're going to learn here and also here. Okay. So right now we just refer to port A and port E. Okay. So why do we need to configure the control register at con? This one, okay, at con. Okay. Why? So you can see from here. So you can see from here. Okay, so you can see from here, table 1.1-2 also suitable. So you can see from here, okay, this one we refer to bit 1 from port A, which is RA0. So you can see here. Okay, so this is the function that you can obtain from port A. Okay, the first one, it is a bidirectional I/O port. Okay, so this means that for RA0, it can behave as digital I/O or analog input. So this means that it have two functions for bit A0. Okay? And then for bit A1, similar like A0. Okay? And then for bit A2, so you can see the functions start to increase up to 4 functions. Okay? We have digital I/O, analog input, AD reference, and then comparator VREF. So the strange name that you first hear, maybe we will learn it later. So but right now we will concentrate only digital I/O and analog input. So why do we need to configure aircon 1? So in order to understand that, we need to go back to this data sheet. So so you can observe the movement of cursor. So we look at the subsection analog to digital. So this is the content of analog to digital, and then if we refer to this one, at con 1. So why at con 1 the value of at con 1 must be 06 hexadecimal or 07. Okay, so this one we need to refer to at con 1. So you can see from here. Okay, what is the value of 06 and 07? So again, you need to find the binary value. So let's say you put 6 first. 6. Okay, this is 4 bit. So this means that for 8 bit, 0, 0, 0, and then 0, 1, 1, 0. So again, we refer to only 4 bit. 4 bit. 0, 1, 1, 0. So 0, 1, 1, x. So x is don't care. So it can be 1, it can be 0. So if we put 0, so 0, 1, 1, 0. Also settable. If we put for 7, 0, 1, 1, 0, 1, 1, 1. Also settable because x equal to don't care. You can put any value just as long as it has certain value. Okay. So right now, as you can see, so whenever we set at con 1, whenever we set at con 1 to either 06 hexadecimal or 07 hexadecimal, so this means that the value for AN0, AN1, AN2 up to AN7 will become digital. Okay. So that's why you need to configure at con 1. We want the port that shares similar function as analog input to behave as a digital I/O. Okay. So if we do not do that, so this means that the microcontroller will be confused, okay, because some of these ports have certain more than one function. So which function that the microcontroller need to perform? Okay. So better, so for port A and also port E, you need to add another configuration by disabling the function of ADC. So you need to put the value here. Okay. Only these two ports, port A and port E. Other than that, port B, port C, and port D, we just use trace X or port X. Okay, you understand? So we proceed. Proceed. Okay. So what is trace X? Trace X is actually a tri-state register or data direction register. We use it to configure a specific port. Okay, let's say when you want to use port A, so this means that we need to refer to trace A. X here will become A. If we want to refer to port C, so this means that trace X here will become C. Okay, so why do we need to use it? Because it is a data direction register. So this means that we want to use port A as output. So this means that we need to set trace A as output. If we want to use port B as input, so this means that trace B need to be set as input. Okay. This one only for the direction only. So the flow would be you go to the flow of the program would the setting need to go to trace first, trace X, then after that then you could go to port X. Okay. So you need to set first. You need to set the value of data direction first before you can write any value to port. Okay. So how do we set? Okay. So by writing, if you want port, let's say port A to behave as input, so this means that we need to write 1 to trace X. How many pin? How many pin? If you want to use up to 4 bit only, so we can declare, we can set 4 bit from trace X as input. Okay, by writing all 1, all 4 bit 1. Okay, like this. Okay, let's say we are using port A. port A. So we know that port A have 6 pin. Here we have A0, A1, A2, A3, A4, A4, A5, then up to A5. Okay, let's say if you want to enable 4 bit only, so this means that this one need to be 1 as input. If you want to set input, this one need to be 1, this one need to be 1, and then this one. Okay, so this means that if we have bit 1, 2, 3, 4, 5, 6, 7, 8. So this means that this one should be 1, 1, 1, 1, and then the rest should be 0, 0, 0. Even though if the port value is 6 bit. Okay? But if you want to, you can always skip the last bit. So that call will be only how many? 6. So if you refer this, so this is equivalent to is equivalent to 4 bit. 4 bit, so that is equivalent to decimal 5 or 0F. So this means if you want to write, so you can always write either 0F or 15 decimal. This one is decimal. You can play around with the numbering format. So if you want to use, to configure, if you want to set certain port as input, so you need to write 1 to the trace register. If you want to set a certain port as output, so you need to write 0 to the trace register. So here X will represent the value of the port, the number, port A, port B, port C, port D, and then port E. Okay, depending on the number of port that the microcontroller can support, and also the port that the programmer wish to use. Okay, and then this is how we write. We program. Okay. So if we are setting the whole port, let's say we are using port D. So port D contain up to 8 bit. Okay, so we can only be sufficient if you want to put. If you put 0, so it means that right after this, port D will become output. It means that only sufficient if you put only single 0. Okay. So like and then if you look at trace B, so trace B FF. So this means that the whole value, the whole bit from port B, which is 8 bit, set to 1111 1111. So this means that it is set to input. Okay, so we set port B as input, and then we set port D as output. So why input, why output? Because 0 means output, 1 means input. Okay. So and then you can see here another one, we have 3C. Okay. Certain half of the first half is set as input, and then the remaining bit, okay, up to 1, 2, 3, 4 is set as output. So you can also do that. You can also mix between output and input depending on the program, the programmer. Okay. And then the arrangement doesn't have to be this. It can be 1 0 0 1 1, depend okay, on the which pin that the programmer want to use. If the programmer want to use more than 1, okay, so the programmer need to set okay, which bit, which port that they want to use. Okay. So another configuration setting here you can see, this means that we want to set only single pin. Okay. So right now we are still dealing with 3 So now we are using port A, port A bit 0. Okay. So port A bit 0, so A0. Okay. So this means that we are right now we are using trace A0. So this means that we want to set port A bit 0 as input. Okay. So we can either do this or we can do this. Okay? And then the other one, yeah, we set port C, port C bit number 5 so equal to 0. So this means that we want port C bit 5 to become as output. So you can also do this 3C bit number 5, 3C5 equal to 0. So this means that this bit will become output. Okay. And then the flow, like the previously drawn flow, after you have properly set the value, whether you want to set it as input or output, then you can proceed to writing or reading to your port. So this is the port that we use, port X. It may refer to either A, B, C, D, or E. Okay, so we use this port if we want to write or read. Okay, value coming or going out from that particular port or bit. So how do we do this? By writing one through program, through C program. So this means that by writing one to the selected port, it can be port A, it can be all the port. Okay, let's say if we want to use port B, we write port 1 to port A. So this means that the port output will produce 1, logic 1, okay, or around 5 volt. Okay, so 1 means that we are writing 1 to the port X. So this means that this port X will write high as an output. Okay. But if we write 0, so this means that the output is low. So this means that the port is actually reading indicator value from load. Okay. So before reading and writing, like I said, the trees, the related tri-state register, you need to configure first whether this port need to behave as input or output. So port and trees both related. Okay. So before you want to use port, you need to configure first through trees. And then this is how you write to port. So first one, we refer data as a character, unsigned character. So data means positive value, unsigned data need to be positive, and the number here, okay, number is up to 55 or 8 bit. Okay, so this means that data, the value of data need to be go into the value from port D need to go into data. So this means that we want port D to become as an input. So this is when we want to read the whole port. For port D, it contains up to 8 bits. So this means that we want to read the whole bit from port D and then copy and then paste it into the variable data. So what if we want to access only certain bit, single bit from certain port? So again, declare first the type of variable that we need to use to hold the value from the port. Okay, so we will start by referring to port D bit number 1. So this means that the value from bit number 1 port D need to be copied and then paste it into variable A. So right now port D bit 1 is an input. Okay, so we need only read data. So you can also write in the form of RD1, the value of bit RD0 put into variable B. So the other one would be assigning operand. So right now we are comparing. Okay. If the value from port B bit 1 is equal to 1, then do something. Okay. And then, or we can also, we don't have to follow the syntax here. We can also put RB1 double equal. If RB1 equal to 1, then we need to write the rest of the code. Okay. So the convention here, you can always use this type, or you can also use this type. Okay. So that one is for reading. Then how about writing? So writing means that we want to write 1. We need to write 1 to the output. Okay. So how do you write? Okay. So you can see here port D equal to F0. So F0 so means that the value here 1111. The value of 40. This is 40. 40 RD0, RD1, RD2, RD3, RD4, RD5, RD6, and then the last one, RD7. Okay, and then the respective bin. Okay, so you are writing F0. So F0 is equal to hexa. Decimal F0 is actually binary, yeah. Term of binary. 1, 2, 3, 4. 1, 2, 3, 4. 8 bit. Okay, so this means that the first 4 bit need to be 0. So 0, 0, 0, 0, and then the last one need to be 1, 1, 1, 1. So if you are writing F0, so this means that starting from port D, bit number 4 up to bit number 7 will produce high or 5 volt, or around 5 volt, and then the rest RG0 up to RG3 will become low. Okay, so this means that you are writing, okay, but you are not writing to the whole port. Okay. You are writing high to only the 4, the last 4 for bit. And then you can also write by using binary format, port C. Okay, so for this case, port C, so you can see here bit 0, the value is 0, bit 1 is 0, and then bit 2, bit 3, bit 4, and then bit 5, all will produce I. Okay. And then the last one, the last two, bit 6 and bit 7 will write 0, 0 here. Okay. So this one according to the number of the bit. If you are writing individual, so you can put dot, port D bit dot RD1, or you can just put RD1. So the value, if you want to write value, so you put 1. So this means that RD1 only, RD1 will become high only. So for port C, bit RC1, 0. So this means that only RC1, port C, bit 1, produce 0. Okay. Do you have any question? Ada soalan? Okay, so we proceed with the new subtopic, okay, which is LED and switch. So LED and switch will concern on the will be related to the output part of the port. So this means that how we want to connect the microcontroller. So basically, LED will be responsible for display purpose. Okay. So this is the output, and then for switch, will be responsible for input. Whether we want to be high or low, that one we will see later on. And then some programming and also circuit. So we look at the first one. So this is what we call LED. So it stands for light emitting diode. So I think you are quite familiar with this LED. We have many colors, red, yellow, green, blue, and so on. So basically, an LED is actually a PN junction that produce light. Whenever adequate voltage is given, it does not necessarily 5 volts, 6 volts. You need to give sufficient voltage. Okay, so they come in different color. So basically, the first generation, the earliest one, they use infrared wavelength. They emit the color, light emit in terms of infrared IR wavelength spectrum. Okay, so modern day, So modern day still use the same thing, IR wavelength. Okay, for right now, okay, so for the current one, they also have ultraviolet wavelength. So basically, what we use, if you go out, you go out to the shop, to the supermarket, and then to the shopping mall, so you can see the presentation might be different, but they are coming from they are being constructed from LED, okay, such as display, mostly display system, and also you can also view, very common. So you can see through devices such as printer, radio, TV, anything to indicate that LED is used. Okay, so the most popular one would be the 7 segment. This one you will learn in our next lecture. Okay, how to program LED. LED 7 segment. Okay. So why do we use LED? Because the advantage over normal intelligent light, robustness, faster switching, and lower energy consumption. Then you can see here the size is small. So that one would be the advantage over normal light, especially the faster switching. Okay, so how do we connect to microcontroller? So we can achieve this by using two configuration. You can see from this table. Okay, the first one here, you can see from the cursor movement. We can always use this type of configuration whereby we call it active low or current sinking mode. So why we call it active low? So you can see here from the configuration itself, we supply the LED. Will use external supply, not from the PIC itself, but from external output. It can be VDD. So it will go through current limiting resistor. After that, it will light up, provided that the output here is low. Okay? Provided that the output here is low. If the output is high, the LED will not light up. Okay? It will remain blank. Okay? It will remain off. Only when you put only when you write 0 to output, so the LED will turn on. So this type of setting we call it active low. And then current sinking, current coming from here will only go through the output port, provided that the output is low. Only 0, so then current can flow inside the microcontroller. So what is the value of R? So you can see here, the calculation. VO, V0 refer to the output voltage for this microcontroller. So the value will be around 4.85. So how do we calculate? VDD minus potential from LED and then divided by the whole. VDD minus LED divided by I LED. So that one will give the value of R. So that one will be precise calculation. Okay, so other than that, if you want to be the most common, the most common configuration, sometimes you can see here for schematic. We normally use around 1K, 1K or 10K. But better if you want to calculate, you can use this equation. Same goes for 85. So why do we call it 85? So you can see here. Okay. Right now, the output or the source will generate energy, will give voltage that will flow through this current limiting resistor, and then it will turn on LED. Only if the output here is 1 or around 5 volt. If the output is 0, so this means that no high signal, the value is not 5 volts, so this means that the LED will not turn on. So that's why we call it active high. So this means that we need to give high during the program in order to turn on the LED or current sourcing, because current is coming out from the source, which is the microcontroller, and going the ground. So we need to pass through R and also LED. Only if the value here is 1. If 0, so no current will coming out here. So LED will remain off. So this is active low. So this is active high. So just to be easy, just to make it easier. If you given the setting must be active low, so this means that you need to write 0 in order to enable the output. Okay. For 85, you need to write 1 in order to enable the output. Okay. So how do we write program? Okay. So for active low, like I said, in order to enable active low, you need to write 0. So for this case, the LED connected to port C, bit number 5. So you can see here. Okay. Right now we want RC5 or port C as output. So we set first the trees. Okay. So right now we want to use specific bit in port C. So we just write down 3C5 equal to 0. So this means that this one will become output. Okay. Or you can always write the whole port equal to 0. And then to turn on, then you write port C 0. Okay. Or RC5 0. Why 0? Because active low. If you put 1, the LED will turn off. Why? Because active low setting, active low configuration. Okay. For active high, okay, the setting is similar. The setting is similar. You want to set bit RC5 as output, this one as output. So 3C should be 0, indicating output. Okay. And then in order to turn on this one, because active 85, so we need to write 1 here. So either we go individual bit or we write the whole thing, port C. Okay. But this one only refer to bit number 5. Or we can use this, RC5 equal to 1. So when you run the program, RC5 will produce 1, and then the LED will turn on. And then we look at the program example. So this one we can make use through the connection of LED. Okay, so blinking of LED is the most common program that we can use to view display from a microcontroller by using LED. So this one we can diversify the program. So we are making this LED to blink at specific rate. So blinking means that we need to turn on the LED here. It can be any color because right now the question not get particular color. So the objective is that need to produce blinking LED. So by blinking means that we need to turn on or turn off for certain period of time. And then the complete cycle of one blink is given as follows. So the flow of the blinking must start turning on of LED and then wait for certain period and then you turn off and then after that wait for certain period. Okay. And then the repetition, okay, you can repeat the looping process. You can repeat as many times you desire. Okay. For example, we want to blink LED 3 times. We can also use those two methods depending on the level of the programmer. Okay. For me, direct method is more suitable for beginner. Okay. For intermediate, for one user, you can use loop or while. So loop or while is a continuous looping because we want to repeat the whole process 3 times. Okay. So we can use direct method, simple but messy. Okay. Why? Because that one you will see later. Okay. And then loop method, effective than the first method. Okay. And then easy to modify. Okay. But this one, if you want to modify, you need to modify the whole program. So this is blinking method using the first method for 3 times, and then the second method you can use loop or while. Okay. Start by begin, then counter, start from 0, and then do the process, the blinking process 3 times, and then need to include the delay, and then after every process, after every process, increment the counter this one, CTR, and then when completed, stop the looping. Okay, so using the parameter here, blink the LED at pin RC5. How many times? 3 times with delay 3 milliseconds. So this means that the LED will turn on 3 milliseconds and then turn off 3 milliseconds, then turn on, turn off 3 times. For direct method, so you can see why it is a messy program. So we need to write and then repeat the whole thing. So this means that this one will turn on and then turn off. So this means that this one first process, and then repeat again. Okay, this one on, up to 2 times, and then the last one 3 times. So you can see here. If you want to change, so this means that you need to change here, 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 and so here. So not effective. Okay, however, if you're using loop method, you can see here, by introducing counter, so we have counter here, I variable, integer I, so starting from 0 to almost 65,000, so very large. Okay, so because the counter only need to count up to 2, so better use char or short. Okay, so why? Because less than 2 counter. Okay, so that one later on. So right now we declare variable I as integer, and then for looping, we are using for looping. For I equal to 0, and then I must be less than 2, and then increment I. So by doing this, so you are writing only this code, a fraction of this code. And then if you want to modify, you can modify here. Okay? No need to modify every code from here. Okay? So right now we want to turn off first and then turn on. And then the delay, 300 milliseconds, 300 milliseconds, then repeat. If the counter is higher than 2, then you go out from the looping. This one for using for loop, and then you can also while loop. This is the parameter, the condition. I must be less than 2. Similar like this one, except that the counter here will be placed after the code, before the curly bracket here. So this one, so you can see here, this is for current syncing, active low, active low. So looking here, low means that the LED will turn on. High means that LED will turn off. Okay. On, off, because of active low. And then for active high, still the same. Code still the same, except that the value here to turn on only RC5 equal to 1. So you can also put FF. So this means that the whole bit will become true. Okay, but since we are not connecting, we are only using RC5. So this one still acceptable. Acceptable. Or you can always put 1, okay, to turn on, and then 0 to turn off. Okay, so this one I think still the same. Okay, but before you are writing, make sure that before you are writing to port, make sure that here trace must be set as output. So the first thing before using port, need to use configure for trace. Okay, and then you can see here, okay, the last slide, only output by using LED to display the output. Then this is switches. Okay, where do we want to use it? We want to use it as an input to the microcontroller. So we can use switches. The switches give input to the microcontroller, but the signal will come from the user or the sensor to indicate whether the condition is high or low. So you can see here, these are the type of switches available. So the definition is a device that can make or break an electric circuit. That can either connect or disconnect electric circuit, or as a controlling device. Controlling device which interrupt the flow of current or right flow of current in coming from another direction. So it will interrupt the flow of current by disconnecting the circuit. Almost all of the electrical and electronic system contain at least one switch. The switch to your handphone, the switch to your laptop, the switch to your light. Okay? So everything contains switch. And then the condition is either on and off. Okay? And then in addition, we can also use switch to control circuit operation through user, where the user can activate or deactivate the whole system of a circuit or specific part of the connected circuit through switching. This one we will see later. This one is for more advanced topic. So right now we look at the general description of switches first. So the switches can either come from mechanical or electrical or electronic switches. It can be either two. So basically, these two mostly used in electrical and electronic system. Okay, and then the type, it can be either mechanical or switch, depend on the where the switch is going to be implemented, okay, where they are going to be assembled. Okay. And then the switches also can have many bases, the category. Okay. You can see here, you can either have number one, latch switch. So what is latch switch? Latch switch, all its state whether on and off when a new command is initiated. That one is a latch. So let's say if you are turning on, so turning on that switch, so this means that the switch will turn on continuously, okay, until the user turn off. Okay. So this means that once you turn on, it will turn on, and then when you want to turn off, you will need to turn it off again. Okay. So on and off depend on the user. And then we have momentary switch. Okay. Momentary switch, or the state only. Okay. Specific command is presented only. So if certain command received, whether to on and off, it will hold. Okay. It will hold. Okay. So you can see here, we have this one refer to mechanical switch. Okay. So we have many types of switch. So basically, it consists of two metal plates touching each other, two metal plates. Okay. So we can see here. And then there are many types. Okay. So you can see from this figure, we have SPST. So this means it's the most basic. Only single line. It can be connect or disconnect. The other one, SPDT. Where we have single pole and then double throw. Common. We can either connect to this one or this one. And then we can also have this one in the form of pair for DPST. Double pole, single throw switch. Both behave like this one, but it is now coming in pair. Okay. And then for this one, you can see here, DPDT, the A1 version of SPST, we have DPDT. Perform same like this one, except that come in double. And then the last one, so you can see multiple, 2P60, 2-pole, 6-throw switch. So this means that you can select which point that you want to connect. And then we have also, this is the latch switch. Depend on user. If the user turn on, it will turn on. And then if the user turn off, it will turn off. Okay. And then we have push button. The push button or momentary switch only turn on when the command is received. So when you press this button, it will turn on. When you lift up your finger, it will turn off. Okay. Unlike this one, when you turn on, it will turn on. Even though when you remove your finger, it will still turn on. Except that when you turn off again, it will turn off. Okay. So that is the difference between push button and so toggle switch. So for electric, we also have electric switches. Okay, so these are the most commonly used. We have transistor, we have MOSFET, and also have relay. So why do we need electronic switches? So sometimes depend on the circuit, whether we want for fast switching, we want to consider speed. We want need to consider speed, so we can always consider this type of switches because they are much more faster than the mechanical. And also you can see especially transistor and the size is smaller compared to the mechanical, and also their durability lasts longer than the mechanical. So how do we connect to microcontroller? Just like LED, we also have active low, we have active high, but the configuration will determine whether it is active low or active high. So for active low or pull up mode, the switch will be in active low configuration. So this is active low. Active low. The switch will be in active low configuration for pull up mode. Okay. That is the state of the pin when the push button is not pressed, is high. Okay. Whenever the push button is not pressed, by board here, current go through RB0. Okay. So we need to check for low to check the switch press even. So if you want, so since the condition is active low, so if you want to write to the microcontroller, we need to push the button so that the current state change from zero, it change from 1 to 0. So when 0, so this means that the microcontroller will start to execute certain function, okay? Because it will only become active when value here becomes 0. And then pull high, this is pull high configuration for switch. So you can see the switch location different. This one located before ground, this one located after supply. So you can see here the condition. Okay, the condition before switch is pressed, here we become 0. Okay, becomes 0. Current in this mode, current flow to the current when the switch is pressed. So this means that whenever the user press this button, current from source will flow into RB0. So this means that the transition of 0 to high or logic 1. So logic 1, so it means that 85. So this will turn on certain process depending on the program. Okay, the output act as 85 output here. So output here, even though it's input, but the output here is 85. So you need to write 1. And then how do we write program to read switch? Okay. So we're going to look at through two modes, active low and also active high. So this is first, how do you do? Firstly, you define your switch name. This is not compulsory, but if you do this, it will be easy throughout the rest of your program, because after this, you just refer the switch as its name, only by the name that you set here, and not the pin number. So, but before doing that, you need to define first. Let's say you define switch, I call it as SW1. Okay. And then the pin number, where is the pin number? So you want to put it as PB1. So this means that you are renaming port B bit 1 as SW1. So the pin number is the pin that connected to the switch. For example, this one, RB0 connected to the switch. Okay, it can be either RB0, RA1, RE1, RB0, RB7, RB5, depend. So some of the examples you can see here. It is not necessary SW1. Okay, you can put switch 1, SWITCH, you can put full name, you can put just a abbreviation, okay, just as long as the programmer understand. Okay, so for this one, we could as define SW1 as at RB0, then PV1 at RE1. So this means that after this, when we want to refer to RB0, we just call up SW1. But first, we need to set RB0 and RB1 since we are reading. We need to set the respective port here as input. So you need to set trace X. So we have two ports here, port B and port E. So this means that trace X, trace B must equal to 1, and then trace E must equal to 1. To be specific, RB0, RB1, so trace X, trace B 0 equal to 1, trace E 1 equal to 1. You need to put respective. If you want to use port B, trace, then trace here should be trace B. Okay, so how do you write the program? In configuration, active low or pull up mode here, active low. So this means that in order to activate the program, the input here must be low. Okay, so it means that it must be 0. Zero. First, set trace. We want to use port B bit 0. So we need to set port B as input. So we need to set trace B0 as input by putting set the value here as 1. And then this one is decimal, or you can also write in the binary format. We want to use only bit 0, so we put 1 here. You can also put 1 throughout the rest of the bit, or here also can, provided that you are not using the rest of this bit. If you are using, so this means that you need to try to avoid, because it will become conflict between the rest of the load. So better if you want to use RB0, so better set bit 0 only. So right now we want to set port B bit 0 as input, and then we want to read. So normally we will put statement if here port B bit 0 equal to 0. Why 0? Because active low. If active low, if 0, so then do something. Depend on the programmer. And then for active high, so you need to put 1 here in order to activate certain code. So first, similar like previous one, we are using the same bit, same port. Set trace B0 equal to 1. Here, set equal to 1, or in this in binary format. So the difference is here. Active low means that the value must be 0. Active high, the value must be 1. So if 0, so this code will not execute anything, will become disabled or active high. If 1, if you press this button here, so this one will become 1, and then the code here will be executed. What happened after this depends on the input here. And then what you see here is what we call key debouncing effect. So normally, this type of problem normally happen. We always related to the mechanical switch. We always have this problem for mechanical switch. So whenever you press a button, whether push button, flip button, toggle switch, so the actual, if you look closely, so it means that two metal parts will come together, will be connected. So you'll be connected, and then the contact will happen. So the contact will happen. That is the theory. But however, in practice, this is not happening. Why? Because of the moving part. We have moving part. So whenever you actually, when you press a switch, it will initially make contact. But for a brief period of time, it will stick. So this means that you will connect, disconnect, connect, disconnect for a few microseconds. So you can see the problem here always happen around few microseconds. So what is the correct number? So you can see from the reference shown here, typically the number of time, number of contact happen from 10 to 100 times. Okay, So if this happen, then the period for this frequency to happen is around 1 millisecond. So basically for 1 millisecond, the switching can be vibrate, contact, from 10 times up to 100 times. Okay. So basically, hardware work faster, but because of the bouncing effect, so this means that the hardware, or it can be microcontroller, it can be IC, the IC will think that the switching, that the vibration is actually signal coming from the user. So because of the speed of the hardware, so this is okay. So because of the speed of the hardware, so you can see the vibration happen here. So the range between 0.01 up to 100 millisecond. So normally happen. So you can see it normally happen during starting and also during ending. Okay. During transition, okay. Transition from low to high or high to low or high to low or low to high. So this is the period that the bouncing effect normally happen. Okay. And then the microcontroller, whenever the microcontroller or the hardware will never know this one coming from bouncing. It just whenever the bouncing effect, it will understand that the user is giving signal. Okay? So this is what the microcontroller see. Okay? Series of high and also low. But actually this one comes from debouncing effect. So this one will cause problem to the program and then to the hardware itself. So how do we solve this problem? Through hardware, we can do three steps here, three options. The first one by doing by building SR latch. The other one RC circuit, and then the last one debouncer IC. So we look at the first one. Okay, but before that, this is for hardware solution. We also have software solution. This one does not need any necessary additional circuit. You just add a routine in your program to solve for bouncing effect. You can either add delay or counter that will filter out the bouncing routine. So you can see from here, the first one would be through by building connecting to a SR latch circuit. So you can see here, it consists of two NAND gate. Then we have two input here. So you can see here. So switching the bouncing effect coming from A and B, whereby A would be the starting, then A would be the ending. So both of these problem will be filtered out, will be eliminated at Q. So the final output here you can connect to a microcontroller. So this one would be the first one. The other one by building an RC circuit. So RC circuit behave like a filter. So this means that it will filter out this spiking, the fluctuation signal here. It will filter out, and then only clean signal like this one will be going out. And then the last one we also have using specific device instrument, which is IC. We call it the bouncer IC. So these are the type, the model that you can use if you want to avoid debouncing, max to 6816, 6817, then 6818. So the number here, indicate that this IC designed for eliminating or minimizing the debouncing effect, and also MC 14490. So this is the connection. Before the switch, normally you would connect the switch directly to the microcontroller, but because of the bouncing effect, you need to put in the middle, after the switch, but before the microcontroller. So you would need to put here, and then signal coming out from here will be have a reduced effect of the bouncing. Before we move on, do you have any question you want to ask? Ada soalan?
No, Doctor.
Tak ada. So we proceed. Proceed.
Yes.
Right now, slide 36. So example program. Write a program and create a circuit to light up 4 LEDs. 1, 2, 3, 4 LED. LED diode that connected to RD4, RD4, and then RD5, RD6, RD7 of a microcontroller. This one, 16F8778. Connect a push button to RC1 that the LED diode will be turned on and off. So blinking effect 5 times with every period 300 milliseconds after the push button is pressed. After you press the push button, LED here will blink. Will blink 5 times. So with delay for every blink 300 milliseconds. So if you want to start the whole process, starting from hardware and then you need to go to software. So this is the first one. You need to assemble the circuit. Okay. So as mentioned earlier, okay, these are the pins that you need to concentrate whenever you want to build a circuit and then program. Okay. You need to connect the active low. This is active low to MCLR. Why active low? If you press this, the signal here will become low, then the system will reset. Okay, so that one you need to build and connect to MCLR. Other than that, supply, you must have the IC must have their own 5-volt supply, positive, and then the other one will be the clock circuit. So right now the current frequency that you want to use is 20 megahertz. Okay, so 20 megahertz. So the range would be around from 20 to 30 picofarad. Both value. This one 20 to 30. This one 20 to 30. Either one. It can be 25, 25, 25, 30, 30. The value must be similar. And then we want to connect LED to port, starting from port RT4 to RT7, RT4, RT5, RT6, RT7. Only 4 bit, 1, 2, 3, 4. And only 4 bit from the total 8 bit. So this means that we are using the higher or the MSB side of our port D. Okay, so you can see here port D7, D5, D6, D7, D6, D5, and D4. We connect to the LED, but the lower bit are D3, RD2, RD3, RD2, RD1, RD0, unused. Okay, just unconnect. Okay, for right now, you just disconnect. Okay, remain unconnected. And then the other one, okay, we need to have input. We have 4 output, which is LED. Then the input must be switch button. What type of switch button? What is the configuration? Either high, active high, or active low. That one not mentioned here. Okay. And then the configuration of LED. It can be active low, it can be active high. So that one not mentioned on the program. So right now, looking at this configuration, so this means that the LED will be enabled for active high. Why active high? The LED will turn on if the value of output from here is high, 1. Okay. Only 1 will turn on the LED. Okay. So that's why we say the configuration here is active high. Okay. And then what about the input? The input must be connected to RC1. So find RC1 here. So this is the switch. The switch configuration that you see here is active low. Okay, why? If you press the switch here, then the value here, the current value is high. So when you press the switch, the current value will change from high to low. So the code written inside this microcontroller will be executed when the switch, the input here become low. Okay, so you can see here from the circuit, the LED will be active high while the switch is active low or pull up current. Okay, so the structure will start from, okay, as mentioned from previous lecture, you can see here, it will start from setting configuration of compiler. So you are using XCH, so the compiler must be XCH. This one you need to follow, okay, the correct syntax. Okay, so the correct code must be same. And then you can start by configuration of the PIC microcontroller, frequency oscillator, watchdog, itu low voltage programming. And then the last one, okay, this is the most important, the crystal frequency. Since you are using 20 megahertz, so this one must be 20 megahertz. And then after this, okay, this is the most important. You need to put in every program. Okay, so this one only depend on the crystal oscillator. If you use 8 megahertz, this one must be 8. So starting from here to here is important, compulsory. So you need to put exactly as it is, except for the value here, the value of the oscillator. And then after that, you are defining RC1 as SW1. So this means that switch 1 here is connected to RC1. Okay. We just call it as RC1. So the main program, okay, after that, after the definition, you go to main program. This is the setup. Okay. Since we are setting this one as output, this one as input, so we need to set the proper trace register. Okay. So we are using trace port D, so we need to configure trace D. We use port B, so we need to configure trace B. So port D must be output, so the value must be 0. Port B is input, so the value must be 1. Okay, so you write this value. Trace D, so format in terms of binary. So you just set everything equal to 0. So this means that all pin from port D will be output. And then trace C, okay, sorry, this one is here, C, C, not B. So and then for 3C, we are using only one pin, which is RC1, or 1 bit, okay, or 1 bit, which is here. Okay, so we can either write only single bit, or we can write all the bit here by writing in the form of binary, okay, 0B, 0, 0, 0, and then here, which is C1, must be I, must be 1 to indicate as input. Okay, then the last one, 0. So right now the switch is only connected to RC1 only. Okay, and then the rest. So you see, even though the value here is 0, so this means that C0, C2, and then up to C7 will become as output, except for C1, because we are setting the whole port, the whole bit from port C. And then after that, when you have properly configured the direction of the data from port D and also port C, port C, so you can go by writing the value here, output, okay, which is port D. So you write 0, 0. Why? Because you want to clear out any initial value from port D. So this one, the code here is located in main subroutine, and then you go to continuous looping. While the condition must be 1 true in order to produce continuous looping. So if switch 1 is equal to 0 here, if switch 1 here, if you press the switch 1, okay, what happens? The condition, the statement here will become true. Then proceed to doing the code here, execute the code here. So if true, do this looping, continuous looping 5 times. 4 times. Okay, 4 times. It's starting from 0 and then 1, 2, 3, 4. Blink 5 times, blink 5 times because you start from 0. Okay, so blink 5 times, period, the period must be 300 milliseconds. So you just write down turn on, and then turn off, turn on, and then turn off. So why F0? Because higher, start from D4 up to D7. So this is F, 1, 1, 1, 1, F on the high side. So you write F0. So why F0? Because 85 also, at the same time, 85. And then to turn off, write again 0. Okay. On, wait for 300 milliseconds. Off, wait for 300 milliseconds. And then go back to the previous for loop, check again the condition is correct. Do again until the condition become false, then you go out. Then the program will go out from this looping. And also, need to monitor the switch condition. Okay. Only the blinking only happen when switch is 0 or active loop. When only switch is press. That's all. So that's all. Okay. End of chapter. Do you have any question? One, we finish early. Before we stop, you have any question you want to ask? Okay, tak ada soalan. So if you have no question, if you